Hi students, in this video we shall talk about the last topic from the chapter matrices, which is elementary operations or transformations. So far we have dealt with operations on matrices. Now we shall discuss operations within a matrix, that is operations applied on rows or columns of a matrix. Such operations are called elementary operations or transformations. Now operations when applied to rows of a matrix are known as elementary row operations, which in short we write as E row operations or transformations, and operations when applied to columns of a matrix are known as elementary column operations, which in short we write as E column operations or transformations. Now we shall see that what these operations are. To begin with, the first one says that a matrix can be transformed by interchanging any two rows of a matrix or any two columns of a matrix, and this interchange of rows and columns is represented by this two-sided arrow. The second one says that a matrix can be transformed by multiplying any row with a scalar or multiplying any column with a scalar. So if k is any number or scalar, then I can apply the operation Ri goes to k times Ri and Ci goes to k times Ci, which means that each element of the ith row is getting multiplied with the number k, or each element of the ith column is getting multiplied with the number k. Now the third operation says that a matrix can be transformed by adding to any row or column a scalar multiple of another row or column, which means that if k is any scalar, then I can apply the operation Ri goes to Ri plus k times Rj, or Ci goes to Ci plus k times Cj, which means that to all the elements of the ith row I am adding k times the corresponding elements of the jth row, or to all the elements of the ith column I am adding k times the corresponding elements of the jth column. So these are the operations. Now for the third operation in particular, if I take the value of k to be equal to 1, then this means that the operation is Ri goes to Ri plus Rj, which simply means that I am adding to the elements of the ith row the corresponding elements of the jth row. Or if k is equal to -1, then the operation becomes Ri goes to Ri minus Rj, which means from each of the element of the ith row I am subtracting the corresponding elements of the jth row. Now these operations hold well for columns also. So this will be Ci goes to Ci plus Cj, or Ci goes to Ci minus Cj. Now let us understand these operations better with the help of an example. So let A be a 2 cross 2 matrix given by say 1, 2, 3, 4. So if I talk about the first operation, and here I have, since only 2 rows, then applying the operation means that I can exchange rows or exchange columns. So for example, if I say that exchange the rows R1 and R2, then the matrix A gets transformed to 3, 4, 1, 2. So I have simply interchanged the 2 rows. All right. Maybe next operation that I would want to apply is say C1 goes to 1 by 3 C1. All right. So what I am doing here is that I am transforming a column by multiplying each of its elements with a scalar. So in this case, the matrix A gets transformed to 1 by 3, 1, 2, 4. So I have just multiplied the elements of the first column with the scalar 1 by 3. And let's talk about the third operation. So if I suppose apply the operation R1 goes to R1 minus R2. Okay. So then the matrix A transforms to what? Now R1 goes to R1 minus R2, which means that I am simply subtracting the elements of the second row from the corresponding elements of the first row. So 1 minus 3 will give me minus 2. 2 minus 4 will give me minus 2, and the second row remains as it is because I am not applying any operation to second row. I am not transforming the second row. So it remains as it is and the matrix A gets transformed like this. So this is all about the elementary row and column operations. That is, what are the operations and how they are applied. Now suppose I have two matrices A, 1, 2, 3, 4 and matrix B, A, B, C, D, and let us take their product A into B. So from our knowledge of multiplication of matrices, we know that this matrix will be 1A plus 2C. The second element will be 1B plus 2D. This element will be 3A plus 4C, and this element will be 3B plus 4D. Alright, so this is the product of these two matrices. Now let us apply a row operation to this product matrix. So suppose I apply the operation R1 goes to R1 plus R2. Then this matrix AB will get transformed to what? I have to add two elements of R1, the corresponding elements of R2. So this will become 1 plus 3 into A plus 2 plus 4 into C, and here this element will be 1 plus 3 into B plus 2 plus 4 into D, and row 2 remains as it is. So this is 3A plus 4C, and this element is 3B plus 4D. Now if you look at this matrix, then this is nothing but product of the matrix 1 plus 3, 2 plus 4, 3, 4 into A, B, C, D. So the row operation that I have applied to the product of matrix A and B is actually getting applied only to the first matrix and not to the second matrix. Now let us see that what happens if I apply a column operation. Say for example, if I apply C1 goes to C1 minus C2, then the matrix AB gets transformed to 1 into A minus B plus 2 into C minus D, and here this entry will be 3 into A minus B plus 4 into C minus D, and the second column remains as it is, 1 into B plus 2 into D, and here it's 3 into B plus 4 into D. So if you look at this matrix, this is nothing but product of the matrix 1, 2, 3, 4 with the matrix A minus B, C minus D, B and D. Alright, so the column operation that you have applied to the product of matrix, it is actually getting applied to the second matrix of the original matrices, that is the matrix B. So you have to remember that whenever you will be applying elementary row operation or column operation to product of two matrices, then the row operation will get applied to the first matrix and the column operation will get applied to the second matrix. Now let us see its application here in this example. It says that use elementary column operation C2 goes to C2 minus 2C1 in this matrix equation. Now when you apply an operation to a matrix equation, then it has to be applied on both sides. Alright, so we will say here applying the operation C2 goes to C2 minus 2C1, the matrix equation becomes, we'll apply the operation here. We have C2 goes to C2 minus 2C1, which means from all the elements of the second column you have to subtract twice the corresponding elements of the first column. First column is not getting affected, so we'll write that as it is. So this will be 2 minus 2 times 4, that's 2 minus 8, that's minus 6. Then we have 3 minus 2 times 3, that's 3 minus 6, that's minus 3. And here on the right hand side, when we apply this operation, then it is actually getting applied to product of two matrices. And when we know that when we apply a column operation to product of two matrices, then it is applied to the second matrix. All right. So here the first matrix would remain as it is, 1, 0, 2, 3. And we'll apply this column operation to the second matrix. So here once again the column 1 remain as it is because it is not getting transformed. For column 2 it's 0 minus 2 into 2, so that's 0 minus 4, and then 1 minus 2 into 1, that's 1 minus 2 minus 1. So this is what the matrix equation becomes after applying this column operation. Now suppose it says that apply the row operation R1 goes to R1 minus 1 by 3 R2. Okay, so then in this case what will the matrix equation become? Let's check. All right, so here on the left hand side, if I apply this, then what I have to do is that from the elements of the first row I have to subtract 1/3 of the corresponding elements of the second row. So 1/3 of the elements of the second row would become 1 here and 1 here, and I have to subtract from the elements of row 1. So this will be 4 minus 1, 3, 2 minus 1, 1, and the second row remains as it is because it is not getting transformed. Now here in the product of two matrices, this row operation will be applied to the first matrix as we have seen here. So it will be applied to the first matrix. 1 minus 1 by 3 into 0, that will be 1 only, and 2 minus 1 by 3 into 3, so that's 2 minus 1, 1. And 0, 3 would remain as it is, and here the second matrix will remain as it is. All right, so you must remember column operation when applied to product of two matrices will be applied to the second matrix, and row operation when applied to product of two matrices will be applied to the first matrix. We shall now use our knowledge of elementary operations to find out the inverse of a matrix. For that, let's first understand what is the inverse of a matrix. Now, when I say inverse, I am referring to the multiplicative inverse, and this shall be calculated only for square matrices. All right. So, I am now taking a square matrix. Let A equal to Aij be any square matrix of order n, then I say that A is invertible, which is same as saying that the inverse of matrix A exists. So A is invertible if and only if there exists a matrix B equal to Bij of the same order n such that AB is equal to BA is equal to identity matrix of the order n, and in this case I shall say that B is inverse of matrix A, which we denote by A to the superscript -1 and read it as A inverse. So product of a matrix A and its inverse is commutative, that is A into A inverse is same as A inverse into A, and that shall give us the identity matrix of the same order. Now let us see with the help of an example. Let us take a square matrix A 1, 2, 3, 7. Now for this square matrix A, there exists a matrix B 7, 1, -3, -2, such that A into B, this is equal to 1, 2, 3, 7 into the matrix 7, -3, -2, 1. Now you can quickly multiply this. So this will be 7 minus 6, that's 1, -3 plus 3, that's 0. Then 14 minus 14, that's 0, and then minus 6 plus 7, that's 1. And let's now calculate b into a. So that will be 7 minus 3 minus 2, 1 into 1, 2, 3, 7. Alright, so this will be equal to 7 minus 6, that's 1. 21 minus 21, that's 0. Minus 2 plus 2, that's 0. And minus 6 plus 7, that's 1. So we can see here that the product AB is same as product BA, and this is generating the identity matrix of order 2. So in this case, I shall say that the matrix 7 minus 2 minus 3 and 1 is inverse of matrix A. Now let us see how elementary operations help us find inverse of a square matrix A. So given a square matrix A of order n, I want to find out its inverse using elementary operations. Now we already know this, that for any given square matrix, A into I is the same as I into A is the same as A. Now we shall make use of this to find out the inverse of matrix A using elementary row operations or elementary column operations. All right. Now you have to remember this, that while for using elementary row operations, we begin with the equation A is equal to I into A, and for elementary column operations, we begin with the equation A is equal to A into I. All right. Now how to go about finding the inverse? For this case, we shall apply row operations on the matrix A so that it gets transformed to identity matrix. That is, we have to select elementary row operations in such a manner that I can change all the elements of the matrix A to the elements of the identity matrix. Now since I'm applying operations to a matrix equation, so it has to be applied on both sides, and since I'm applying elementary row operations, which means on the right hand side where I have product of these two matrices, it will be applied only to the first matrix and the second matrix will remain as it is. So the operations that I applied to the matrix A to transform it to the identity matrix, the same operations will get applied to the identity matrix and it will transform into a new matrix, say B. And this second matrix will be copied all throughout this process. So here I will arrive at this situation now, that I is equal to B into A, which gives me that the matrix B is A inverse. That is, this entire process will lead me to this equation, and from this equation, this matrix B that I will obtain will give me the inverse of the matrix A. Similarly here, while applying elementary column operations, I begin with equation A is equal to A into I, and now I apply the elementary column operations in such a manner that this matrix A gets transformed to the identity matrix. On the right hand side, when I apply the same column operations, they will get applied to the second matrix, and the first matrix will be copied as it is all throughout. The operations when applied to the identity matrix will transform it into a new matrix, say B, and this gives me that the matrix B is A inverse. So in this entire process, this matrix B that will be obtained will give me the inverse of the given square matrix A. Now you have to remember 2 points here. First, for applying elementary row operations, to find the inverse of a matrix, we have to begin with this equation, and for column operations, we have to begin with this equation. We can't exchange the use of these two. And for the same reason that the operations are applied here to the first matrix and here to the second matrix, we can apply only row operations or column operations. We can't mix the two. That is, to a same question we can't apply somewhere row operations and somewhere column operations. We have to stick to any one. We shall now quickly look at a few examples and see how we can evaluate inverse using elementary operations. So here's the first question. We have to find inverse of this 2 cross 2 matrix using elementary operations. So let us begin by naming the given matrix. Let A is equal to 2, 1, 5, 3. Now, since we have to apply elementary row operations, so we know that we have to begin with the equation A is equal to I into A. Let's plug in the matrices. It's 2, 1, 5, 3 is equal to identity matrix of order 2, so 1, 0, 0, 1 into the matrix A. I know that I have to apply elementary row operations which will not affect my second matrix here, so I am not writing the complete matrix, so just writing A here. Now I have to apply the operations in such a manner so as to convert this matrix into identity matrix, right? So I have 4 elements here, 1, 2, 3, 4, from which I have to convert this into 1, this into 0, this into 0 and this into 1. Now there is a specific pattern which we will follow, using which you can do this question with much ease and without any calculation error, and that is, you make this element 1 first, and then you make this element 0, then you make this element 1, and then you make this element 0. So there is this U pattern that we are going to follow for 2 cross 2 matrices in case of elementary row operations. Alright, so which means that I have to first make this entry here 2 as 1, which I can either do by transforming the first row by multiplying it with 1 by 2, or I can from the first row subtract the second row. So 2 minus 1 will give me 1. So I have to think of the operation which can help me do this. You can apply any operation. So here I am applying the operation R1 goes to R1 minus R2. Alright. So here on the left hand side this becomes 2 minus 1, 1. 5 minus 3, 2. The second row remains as it is. And here it will be 1 minus 0, 1, 0 minus 1, minus 1. The second row remains as it is, and we copy A as it is. Now next we have to make this element over here 0. How we can do that? We can subtract from this one, which will give me 0. So I now apply the operation R2 goes to R2 minus R1. So this gives me here the first row remains as it is. The second row 1 minus 1, 0, 3 minus 2, 1. Here on the right hand side the first row remains as it is. 0 minus 1, that's minus 1, and 1 minus minus 1, that's 2 into the matrix A. Now next I have to make this element 1, which I have already made. Alright, so the next I have to make this element 0. How we can do that? From this 2 I can multiply this by 2 and then subtract, right? So R1 now goes to R1 minus twice of R2. Alright, so the second row remains as it is, and from the first row I have to subtract twice of the corresponding elements of the second row. So 1 minus 2 into 0, that was 1 only, and 2 minus 2 into 1, that's 2 minus 2, 0. Here on the right hand side what we will have? 1 minus minus 2, that's 1 plus 2, 3, and here I will have minus 1 minus 4, so that's minus 5, and the second row remains as it is into A. Now we have achieved the identity matrix here, so which means that this matrix, which identity matrix has been converted to, gives me the A inverse. So from here you will say that hence A inverse is equal to 3 minus 5 minus 1, 2. Wasn't this simple? Now here's another question which says find inverse of this 2 cross 2 matrix using elementary column operation. So once again we begin by naming the matrix. So let's A is equal to 1 minus 3, 6, 5, and since we have to apply the column operations, therefore we know that we have to begin with the equation A is equal to A into I. Let's plug in the matrices. So we have 1 minus 3, 6, 5 is equal to A into 1, 0, 0, 1. Now once again, I am not putting the matrix for this A here because I know that column operations will not affect the first matrix. Now once again, I have to apply operations in such a manner that this 2 cross 2 matrix gets converted into identity matrix. So we have here 4 elements, out of which I have to convert this to 1, this to 0, this to 1, and this to 0. Now when we apply column operations, then the pattern that we follow is that we make this element 1 first, then next this element 0, then this element 1, and then this element 0. So there is a closing square bracket pattern that we are going to follow in 2 cross 2 matrices for elementary column operations. So let's get started. We have to make this element 1, which is already there. Now we have to make this element 0. How we can do that? 6 minus 6 into 1. So we will apply the operation column 2 goes to column 2 minus 6 times column 1. So the column 1 remains as it is, 1 minus 3. Now this is 6 minus 6, that's a 0, and 5 minus 6 into minus 3, that's 5 plus 18, 23. And here on the right hand side we have A into the first column remains as it is, then 0 minus 6, that's minus 6, and 1 minus 6 into 0, that's 1 only. Now we have to make this element 1, which we can do by taking the scalar multiple of this column, which is 1 by 23. So C2 goes to 1 by 23 times C2. So this now becomes, the first column remains as it is. This is 0, this is 1. Here on the right hand side, the first column remains as it is. This is minus 6 by 23 and this is 1 by 23. All right. Now we have to make this last element 0. How we can do that? Multiply this by 3 and then add to this. So C1 goes to C1 plus 3 times C2. So here this becomes 1 plus 3 into 0, that's 1 only, minus 3 plus 3, that's 0, and the second column remains as it is. Here on the right hand side we will have 1 plus 3 into 6 by 20 minus 6 by 23. So that's a 1 minus 18 by 23. So that will be equal to minus, that will be equal to 5 by 23. And here the second element, it is 0 plus 3 by 23. So that's 3 by 23. And the second column remains as it is, minus 6 by 23, and here 1 by 23. So from here, since we have converted this into identity matrix, so this matrix gives us the inverse, and hence we write our final statement that A inverse is equal to the matrix 5 by 23 minus 6 by 23, 3 by 23, and 1 by 23. Now here's the third question, which says find the inverse of this 3 cross 3 matrix using elementary transformations. Now here it is not specified row or column, so it's completely your choice whether you use row transformations or column transformations. I'll be using row transformations to find out the inverse of this matrix. Now since we are using row transformations, so we know that we have to begin with the equation A is equal to I into A. Let's plug in the matrix. Here we have 1 minus 1 0, 2 3 minus 2 minus 2 0 1 is equal to identity matrix of order 3, that's 1 0 0 0 1 0 0 0 1, and then this matrix A as it is. Now this question, if comes, it comes for 6 marks. The 2 cross 2 matrix comes for 4 marks. So here these 6 marks straight into your pocket by using this small little trick or strategy, you can say. Since we have these 9 elements over here, 3 cross 3 matrix, and we know that we have to convert this matrix into identity matrix. So we have to convert this into 1, this into 0, this into 0, this into 0, this into 1, this into 0, this into 0, this into 0, and this into 1. Now there is a fixed pattern with which we will do this, and that is we make this 1 and then we make this 0, then we make this 0, and from here we move to the next diagonal element and make this 1, and then we make this 0, then here we make this 1, then this 0, then this 0, and then finally this 0. So there is this kind of pattern that we will be following, and you can say that it's a W pattern that you will be following to transform to find inverse of a 3 cross 3 matrix using elementary row operations. So let's get started. We first make this entry 1, which is already there. Then we next make this entry 0, which we can simply do by applying the operation R2 goes to R2 plus R1. Alright, so here this matrix becomes 1, 2, minus 2. The first row remains as it is. The second row becomes 0, 5, minus 2, and the third row remains as it is. So 0, minus 2, 1. Here on the right hand side, the first row remains as it is, 1, 0, 0. For the second row, we have to add the elements of row 1, the corresponding elements. So 0 plus 1 will give me 1, 1 plus 0 will give me 1, and 0 plus 0 will give me 0. The third row remains as it is, this into A. Now the next is we have to make this element 0, which is already there. Next we have to make this diagonal element 1. Now what we can do is that I can take 1 by 5 of this row, right? So R2 goes to 1 by 5 of R2. That will help me make this element 1. Or alternately what I can do is that I can multiply this row by 2. That will help me get the value minus 4 here, and then I can add to this. So alternately I can apply the operation R2 goes to R2 plus 2 times R3. Okay, you can apply any one of the two operations. I'll be going by this operation. So here this will give me the first row and the third row remains as it is, 1, 2, minus 2. So let me copy them first. 0, minus 2, 1, and here on the right hand side also 1, 0, 0, and here 0, 0, 1 remain as it is. This A remains as it is. The second row has to go to 1 by 5th of it. That is, all the elements go to 1 by 5 of it. So this is 0, this is 1, this is minus 2 by 5, this becomes 1 by 5, this becomes 1 by 5, and this becomes 0. Alright, so now we have to make this entry 0. So for that what we can do is that I can multiply this by 2 and then add to this. So we apply the operation R3 goes to R3 plus 2 times R2. Alright, since we are transforming R3, so let's copy the first and the second row as it is. 1, 2, minus 2. Then we have 0, 1, minus 2 by 5. And third row we will evaluate. Here on the right hand side, this is 1, 0, 0. Then 1 by 5, 1 by 5, and 0 as it is, and this A as it is. Alright, now R3 goes to R3 plus 2 times R2. So we have to multiply the elements of the second row by 2 and then add them to the corresponding elements of the third row. Right, so 0 plus 2 into 0, that's a 0. Minus 2 plus 2, that's 0 again. And then we have 1 minus 4 by 5, that's 1 by 5. Here on the right hand side we have 0 plus 2 by 5, so that's 2 by 5. Next also 0 plus 2 by 5, 2 by 5. And then next we have 1 plus 2 into 0, so that's 1 only. Alright, moving on to the next element. Now we have to make this element 1. So for that what we will do, we will multiply the third row by 5. So it will make this 1, right? So R3 now goes to 5 times R3. Okay, once again the first and the second row remain as it is. So let's copy them down. 1, 2, minus 2. Then we have 0, 1, minus 2 by 5. And here on the right hand side we have 1, 0, 0. Then 1 by 5, 1 by 5. and 0, and this A remains as it is. Now multiply the third row, each entry by 5. So this becomes 0, 0, 1, and this becomes 2, 2, and 5. Fantastic. So now we have to make this element 0. How do we make that? We multiply this by 2 by 5 and then add to this. So R2 goes to R2 plus R2 goes to R2 plus 2 by 5 times R3. So here this matrix on the left hand side becomes first and the third row would remain as it is. So we copy them down, 1, 2, minus 2. Here it's 0, 0, 1, and here on the right hand side it's 1, 0, 0, and 2, 2, 5, and this A as it is. Now let's evaluate the second row. So it's 0 plus 2 by 5 times 0, so that's 0, 1 plus 2 by 5 times 0, so that's 1, and minus 2 by 5 plus 2 by 5, so that will be equal to 0. Here it's 1 by 5 plus 4 by 5, that's 1. 1 by 5 plus 4 by 5, that's 1, and 0 plus 2 by 5 into 5, so 0 plus 2, this entry will be equal to 2. Now what is the next thing that we have to do is make this entry 0. So what I can do here is that multiply this by 2 and then add to this. So we apply the operation R1 goes to R1 plus 2 times R3. Since R2 and R3 are not getting affected, so let's copy them down. This is 0, 1, 0, and here 0, 0, 1, and here on the right hand side we have 1, 1, 2, and 2, 2, 5, and this A as it is. So R1 goes to R1 plus twice R3. 1 plus 2 times 0, that's 1. 2 plus 2 times 0, that's 2, and minus 2 plus 2, that's 0. Here on the right hand side it's 1 plus 4, that's 5, then 0 plus 4, that's 4, and then 0 plus 10, that's 10. Now next what we have to do is make this entry 0. How do we do that? Multiply this by 2 and then subtract from it. So we apply the operation now. Let me write it here. So it's R1 goes to R1 minus twice of R2. All right, the first row is changing and the remaining are not changing, so we'll copy them down. It's 0, 1, 0, and 0, 0, 1 here on the left hand side. On the right hand side we have 1, 1, 2, and then 2, 2, 5, and then this getting multiplied with the matrix A. So on applying this operation, this row now becomes 1 and then 0 and then 0. Here on the right hand side we will have 5 minus 2, that's 3, and then 4 minus 2, that's 2, and then 10 minus 4, that's 6. So we have reached to the identity matrix, and hence this matrix will be A inverse. So we write down our conclusion that hence A inverse is equal to the matrix 3, 1, 2, 2, 1, 2, and then 6, 2, 5. Alright, so this is how you go about finding inverse of a 3 cross 3 matrix. And now I want you to quickly pause the video and do it yourself, that find the inverse of this matrix using elementary transformation. You may apply row or column as per your choice. I would recommend you to use column operation so that you know the procedure once. Alright, so here's the solution. I have done this using elementary column operations. You could have done it using elementary row operations. The answer would remain the same, and this is A inverse. I want you to notice two things here. First, for a 3 cross 3 matrix, to find its inverse using column operations, we will follow this kind of pattern, that is a 3 looking pattern. So we'll make this entry 1, then this 0, then this 0, then this 1, then this 0, then this 1, then this one 0, next this 0, and next this 0. So it's a 3 looking pattern that we will follow, and then apply the operations accordingly. This is how you apply, and the final answer will come out to be this. Now here in the first step, I have applied two operations simultaneously, which you can very well do if you can do it easily. Otherwise, if you think that you will get confused in doing such a thing, then you might skip doing them together and then apply one after the other. All right, so this was all about finding inverse of a matrix using elementary row operations, a pretty important topic. So just get these 6 marks straight into your pocket by practicing using these small little tricks. Thank you.